Welcome to Chapter 7, Ionic Equilibria, Acid and Base. Let's learn about how to identify conjugate acid and conjugate base according to Bronsted-Lowry theory. According to Bronsted-Lowry theory, conjugate acid is the species formed when a proton is added to a Bronsted base. Okay, what is this meaning? Okay, let's look at the reversible reaction equation. Okay, we have conjugate acid, Bronsted base. Okay, it is stated that conjugate acid is a species formed when a proton is added to Bronsted base. Okay, so let us compare Bronsted base and conjugate acid. Okay, before the reaction, H2O is a base. Then after the reaction, water accept proton, or a proton is added to water, and then water becomes conjugate acid. When water becomes H3O plus hydronium ion, the hydronium ion is known as conjugate acid. So it is quite easy to recognize Bronsted base and its conjugate acid. That is, if it's a base, then the pair look at it. Okay, we have H2 and it becomes H3. One hydrogen is added, H plus is added. So it's conjugate acid. Okay, now let's look at conjugate base. Okay, conjugate base is a species formed when a proton is removed from a Bronsted acid. Okay, now we compare another one. Okay, when we know that this is acid, we know that acid donates proton to H2O. Okay, then what happened here is when it donates proton, then it will form conjugate base, that is carbonate ion. So if we look at carbonate ion, we know that a proton is removed from a Bronsted acid. Okay, so let's look at here. This one I put minus because one proton is removed from the Bronsted acid. So Bronsted acid, the pair will be conjugate base. And then we look at before reaction, there's one hydrogen. After reaction, one hydrogen is removed. Okay, so again, remember Bronsted acid, conjugate base, acid, base. Bronsted base, conjugate acid, base, acid. Okay, these are the relative strengths of conjugate acid-base pairs. The stronger the acid, the weaker the conjugate base. The stronger the base, the weaker the conjugate acid. Okay, now let us learn how to write balanced chemical equation for dissociation of weak acid. Okay, include the phase. Remember when we write reversible reaction equation or dissociation of weak acid or weak base, we must include the phase and also reversible arrow. Okay, so it's stated that HCN is a weak acid. Okay, so we write down HCN and remember aqueous. Okay, dissociate partially in water. Water is liquid. Okay, so how am I going to write the products? Okay, it's very easy. Remember one thing. If it is acid, acid will produce H3O plus hydronium ion. Okay, so I will put down hydronium ion first to show that this is acid. Okay, then next one. Okay, so what we have solved is, okay, we know that this is acid. So if one is acid, water will react as base. So this part has been balanced. So base, then you see here, it becomes conjugate acid because from here to here, one proton has been added. 2 becomes 3. Okay, now we solve another one. That is, if there's acid, another one must be conjugate base. Okay, so what happened is HCN will donate 1 proton. Okay, HCN will donate 1 proton because it's acid and becomes conjugate base. So this one donate proton. So you see here, there's 1 hydrogen here, and then after the reaction, there's no more hydrogen. So the acid-base conjugate pair is easy. Acid, conjugate base. Base, conjugate acid. Okay, let us try weak base. Okay, for weak base, it's the same step. We write down CH3 and H2 equals plus H2O water. Okay, so remember, if it's a base will produce OH minus. That's why I write down OH minus first. Okay, so in this case, CH3 and H2 is a base, so H2O will react as acid. Okay, so if it's acid, another one will be conjugate base. Okay, next one, if we know that it is a base will accept proton. Accept proton means, okay, initially we have 2 hydrogen. So after it accept proton, it becomes 3 hydrogen. And don't forget the charge because it has accept 1 proton. Whereas acid donate 1 proton here. Okay, so this is the conjugate acid. Okay, now, just now the question didn't ask to identify the acid-base conjugate pairs. It just asked to write the balanced chemical equation. So it is just enough if you just write the reversible reaction equation for the dissociation of weak base in water. Okay, now in this question is different. It has highlighted that we need to identify the acid-base conjugate pairs. Okay, so the first thing is you must know which one is acid, which one is base. Okay, so it's quite easy to identify. That is, you count the hydrogens of each substance before and after the reaction. Okay, now we do one by one. Okay, let us look at hydrogen bromide first. Okay, HBr. Okay, before, after. Okay, before here has 1 hydrogen. After that, 1 hydrogen is decreased, meaning that from HBr to Br minus, 1 proton is donated. So when we donate proton means it is acid. So the pair will be conjugate base. Okay, now let's look at ammonia. Ammonia, before it has 3 hydrogen, then after reaction it has 4 hydrogen. It gains 1 proton. So if we gain proton, if a species gain proton, it is base. And then after the reaction, when the species accept a proton, we know that it is called conjugate acid. Okay, for this type of question, what you need to do is remember to write down acid, base, conjugate acid, conjugate base. And don't forget to draw the line to show that they are one pair. Okay, so again, I will emphasize again. To identify which one is acid or base, counts the number of hydrogen before and after reaction. If the number of hydrogen become less, then it is acid. If the hydrogen becomes more, it is base. And then the pair is just opposite. If base, conjugate acid. If acid, conjugate base. That's all for this chapter, writing the balanced chemical equation for dissociation of weak acid, weak base, and also to identify the conjugate acid and conjugate base.